வாகை சூடவா.
Good morning students. Today we are going to see a topic in chemistry regarding NEET, that is ionic equilibrium in solutions. As the name clearly implies that this is an equilibrium that involves ions. For example, when you add hydrochloric acid to water, it dissociates to give H3O plus ions and chloride ions. So, in this it is very clear that this equilibrium involves ions. Okay. Now, we are going to see very clearly about this equilibrium, lot of problems involved in this chapter. We are going to see everything in detail related to NEET. Okay. Now, before that we are going to see certain terminologies involved in this chapter. First one is electrolyte. What do you mean by electrolyte? An electrolyte is one which conducts electricity. How does an electrolyte conduct electricity? It conducts electricity because it dissociates to give ions. When there are ions, ions migrate or ions move, you will have conduction. Okay? Now, the opposite to that is non-electrolyte. What do you mean by non-electrolyte? A non-electrolyte is one which does not conduct electricity. Why it does not conduct electricity? The reason being there are no ions, there is no dissociation. Example, sugar, okay, urea, these won't dissociate. Since it does not dissociate, there are no ions, there is no conduction. Okay. Now, the next one is types of electrolytes. Students, there are two types of electrolytes. One is strong, another one is weak. As the name clearly suggests that strong electrolyte means you will have lot of ions. Lot of ions produced as a result of almost complete dissociation. Strong electrolyte examples: strong acids, strong bases, salts, etc. Strong acid, for example, hydrochloric acid. Strong base, sodium hydroxide, potassium hydroxide. Salts results as a result of reaction between these acids and bases. Next one is weak electrolyte. What do you mean by weak electrolyte? A weak electrolyte is one which dissociates feebly, that means to a lesser extent. So, only less number of ions are present in the solution. Since less number of ions are present in the solution, your conduction automatically will be less. Okay. Now, the next important part in this chapter is ionization of weak electrolyte. As I told you already, a weak electrolyte won't dissociate completely, it dissociates feebly. Since it dissociates feebly, there will be equilibrium between the undissociated molecule and the dissociated ions. Now, based on this, we are going to see a law that is called Ostwald's dilution law. What is this law? This law relates three things. One is degree of dissociation, the next one is dissociation constant of a weak acid or a weak base, both can be included, and the next one is concentration of the solution that is involved. Okay. Now, we are going to see that. First one is alpha, that is degree of dissociation. Degree of dissociation is nothing but a ratio of number of molecules dissociated to the total number of molecules. Okay. For example, suppose you are having 100 molecules, 10 molecules dissociated, the ratio is 10 by 100. 10 by 100 is nothing but 0.1, that is what is called degree of dissociation. The next one, there is an equation given in this. You take a weak acid, for example acetic acid, it dissociates to give what? Acetate ion and hydrogen ion. There is an equilibrium involved between these two. Okay. Now, as it is in equilibrium, you can write an equilibrium constant for this. Equilibrium constant Ka is equal to product of concentration of products to concentration of reactants, that is what given here. And another thing is Ka is given, A refers to acid, a weak acid, that is why Ka given. Similarly, if we use a weak base, then we can use Kb. Here you see Ka is equal to H plus into CH3CO minus over CH3COOH. Okay. The next thing, now we are going to derive an equation involving these things. Now you see initial number of moles what you have taken. In the case of acetic acid, you are taking 1 mole. At the start there is no dissociation, so H plus acetate ions are not present. Okay. Now the next thing is degree of dissociation. Degree of dissociation of acetic acid given is alpha. Okay. So now number of moles at equilibrium is starting, you are having 1 mole, degree of dissociation is alpha. So the rest at equilibrium will be automatically 1 minus alpha. Since alpha got dissociated, the amount of H plus and acetate ions formed will be automatically alpha. Now the last thing given in this is equilibrium concentration. Equilibrium concentration, how will you get? You have to subtract the degree of dissociation with the initial concentration. For example, what is given here is C into 1 minus alpha, which is nothing but C minus C alpha. So C alpha is the concentration that you have to subtract. How will you get? Initial concentration multiplied by degree of dissociation. How much is the concentration that is lost? That will be equal to the product's concentration. So what is the concentration in the product side? H plus C alpha, acetate ion also C alpha. Now you have to substitute in the equation previously that you are having. What you had already is Ka is equal to H plus into CH3CO minus by CH3COOH. You are substituting the values. When you are substituting the values, for H plus it is alpha C, for acetate ion it is alpha C, for acetic acid it is C into 1 minus alpha. Now C you can cancel, 1 C gets cancelled. So the resulting equation becomes alpha squared C by 1 minus alpha. Okay. Now the most important thing is alpha degree of dissociation you can neglect when it is less than 5%. Students should remember this, it is very important while you are doing calculations. Okay. So based on that, from that what you are getting is Ka is equal to alpha squared C here, because alpha you have neglected. So 1 minus alpha simply becomes 1, so that we are not putting it in the denominator. So Ka is equal to alpha squared C, your alpha squared will then become Ka over C, then alpha is equal to root Ka over C. This is very, very important. This formula is very, very important. Based on this, we are going to see certain problems in this chapter. Students should remember this formula. Certainly problems will be asked. Now we are going to see certain problems in this chapter. Okay. The first one is calculate the degree of dissociation and concentration of H3O plus ions in 0.01 m solution of formic acid. What is the data given? Ka given. Another data what is given? Concentration given. Okay. What is asked? Alpha is asked. Now we are having the formula, just now we have derived alpha is equal to root of Ka over C. Okay. Now Ka value is given. What is that? 2.1 into 10 power minus 4, that you have substituted. For the concentration 0.01. Okay. So 0.01 is nothing but 10 power minus 2. So when 10 power minus 2 go up, it will become 10 square. that is what we have got in the next step. So, root of 2.1 into 10 power minus 4 into 10 square. Now, 10 power minus 4 into 10 square, when the base same, you can add the powers. When you add the power 10 power minus 4 plus 2, you will get 10 power minus 2. So, the equation or the simplification becomes root of 2.1 into 10 power minus 2. Root of 10 power minus 2 is what? 10 power minus 1. Root 2 we know value, that is 1.414, that is a value that we have got. So, finally, alpha is equal to 1.4 into 10 power minus 1. The next thing, 1.4 into 10 power minus 1, you can write it as 0.14. Now, we have got alpha. So, what is asked? One is alpha, that we have found out. The next thing is concentration of H3O plus. From the expression that you have derived, in that H plus you have substituted as C alpha. Students should not forget this. H plus is equal to C alpha. So, now you have derived alpha, you substitute for that plus concentration that is given in this. Okay. Now, if you substitute the concentration, what will you get? 0.14 into 0.01. So, 0.01 is actually 10 power minus 2. So, 0.14 is actually 1.4 into 10 power minus 1. So, 10 power minus 1 into 10 power minus 2, that becomes 10 power minus 3 mole per liter. So, in terms of molarity, it is given over here. So, in this problem you have found out one alpha, and the next thing is concentration of H plus hydronium ion. Clear? Okay. Now, we are moving on to the second problem. In this problem, I am going to read out the problem. Calculate the degree of ionization NH3O plus of 0.01 m acetic acid solution. Equilibrium constant of acetic acid given. Exactly same as the previous one. We know the formula for degree of ionization, that is root of Ka over C. Ka is given here. What is the value? It is 1.8 into 10 power minus 5, okay, by concentration. What is the value of concentration that is given? 0.01 m. So, we have substituted 0.01. Okay. Root of 1.8 into 10 power minus 5, 0.01 is actually 10 power minus 2. When it goes up, the power will be positive. So, that means it is 10 square. Now, overall 10 power minus 5 into 10 square is what? 10 power minus 3. Okay. 10 power minus 3. Now, the next thing is what we are doing, if it is in odd value, you can't change from root to the normal value. What I am going to do is 1.8 I am going to write as 18. So, 1.8 into 10 power minus 3 becomes 18 into 10 power minus 4. So, root 18 will be, what is the value for root 18? Root 16 is 4. Okay. So, it will be around 4 something. The value for that is 4.24. Root of 10 power minus 4 is actually what? 10 power minus 2 mole per liter. That is, in terms of molarity, we have found out the degree of dissociation. Okay. And the next thing what is asked in this problem, H3O plus. Based on the same way, you can find out the. Now, we move on to the third problem. I am going to read out that 0.01 m solution of acetic acid is 1.34% ionized. In this, what is given? Alpha is given. In this, alpha is given. What is asked, you see, what is the ionization constant of acetic acid? So, previously in the last two problems, Ka is given, alpha is asked. In this problem, alpha is given, Ka is asked. So, as I told already, problems will be asked, one is alpha can be asked, another one Ka can be asked. So, students should be very clear in this, and as I told already, if your dissociation is less than 5%, you have to substitute it as it is, that is alpha squared C by 1 minus alpha only. We are going to see that in this problem. So, the first equation is Ka is equal to alpha squared C. What is alpha given? 1.34%, 1.34%, that means divided by 100. When you divide by 100, what will you get? 0.0134, that you have to square it, okay. Into concentration, what is given? 0.01 by 1 minus alpha, 1 minus alpha, 1 minus alpha is 0.01, that we have substituted, okay. 0.0134 square is actually 1.79 into 10 power minus 4 into 0.01, 0.01 is actually 10 power minus 2 by 0.01, what is the value? 0.99, okay. The next thing, 1.79 into power you add, 10 power minus 4 into 10 power minus 2, what will you get? 10 power minus 6 divided by 0.99. Finally, what is the answer? 1.80 into 10 power minus 6. So, of all the three problems, we have seen two things. One is Ka can be asked, or in other words alpha can be asked. Students should be thorough with these problems. These type of questions certainly can be asked in the NEET exam. Okay, the next part is relative strength of two weak acids. For example, we know already in the Ostwald's dilution law, alpha is equal to root of Ka over C. Okay. Now, if two weak acids of equal concentrations taken, for the first acid put alpha 1, degree of dissociation as alpha 1. For the second acid put degree of dissociation as alpha 2. So, alpha 1 is root Ka 1 over C by alpha 2 is root Ka 2 over C. What is given in this? Equimolar concentration. That means concentration will be same, that you can cancel it out. So, once you cancel the concentrations, the formula becomes alpha 1 over alpha 2 is equal to root of Ka 1 over Ka 2. Similarly, for a base, alpha 1 over alpha 2 is equal to root of Kb 1 over Kb 2. What is Ka? What is Kb? Ka is dissociation constant of a weak acid. Similarly, for Kb, dissociation constant of a weak base. The last two lines given, that is very important. For a weak acid, always Ka1 will be greater than Ka2 will be greater than Ka3. Similarly, for bases, Kb1 greater than Kb2 greater than Kb3. What is this? Ka1 means, for example, you take sulfuric acid. Sulfuric acid can dissociate two times. First, H2SO4 gives H plus plus HSO4 minus. In the second step, HSO4 minus dissociates to give H plus plus SO4 2 minus. So, 2 times it gets dissociated. In that case, for the first dissociation it will be Ka1, for the second one it is Ka2. Suppose if it is H3PO4, in that case it will dissociate 3 times. For those cases, this formula will be quite useful and essential. That is, dissociation constant of first one will be greater than dissociation constant of the second, in turn dissociation constant of the third one. Okay? You have to do these problems, master this. Questions certainly will come in these areas. Previously it has been asked. Okay? Good morning, students. Today we are going to see a topic in chemistry regarding NEET, that is ionic equilibrium in solutions. What we have seen is the most important thing, Ostwald's dilution law. in this formula certainly questions can be asked. We have seen 3 problems, right. In this formula one Ka can be asked, another one alpha can be asked. The one important thing that you have to keep it in mind is, if alpha is less than 5%, you can't neglect alpha in the denominator. You have to put it as 1 minus alpha as it is. If it is greater than 5%, you can put 1 minus alpha as 1 itself. This is you have to remember. We have seen in the third problem that percentage, we have substituted exactly the percentage of ionization as it is. We have not neglected that, you have to keep it in mind, third problem, right. And here alpha can be asked, Ka can be asked, both can be asked, and certainly problems can come in the coming NEET exam 2020. Moreover, chemistry, as we all know that we have 45 questions, and from this chapter in particular you can expect 3 to 4 questions, mostly problems being asked. Sometimes theory related questions are also being asked that we have to be familiar with. Okay, certainly you people all can do those things. Most important thing is you have to solve lot of problems, work out problems. The one important thing is you should not write everything, you should not write the formula, keep the formula in mind, substitute straight away, what are all the data is given, substitute it straight away, simplify the calculation. Calculation you should not do because it will consume lot of time. So, time management is very important in the NEET exam. So, all students keep that in mind, do not write everything as what we have given here in this, because for better understanding it has been given like that. While you are doing it in the exams, avoid this, skip certain steps, but you have to do it correctly. Okay. In the case of Ostwald's dilution law, what we have seen is a weak acid in equilibrium with its ions. In the same way, a weak base can be in equilibrium with its ions also. For example, ammonium hydroxide, if it undergoes dissociation, it dissociates feebly. What will you get? Ammonium ion and hydroxide ion. In that case, if you write the equilibrium, constant, what will you get? Instead of Ka, you will get Kb. Kb is equal to NH4 plus into OH minus by NH4 OH. In this case, what you are getting? Instead of H plus, you are getting OH minus. So, the same problem, how can they modify is, instead of H plus, you might be asked OH minus. OH minus concentration can be asked. Same way, instead of Ka, Kb can be asked. So, the most important thing you have to keep it in mind always is H plus equal to C alpha, H plus equal to C alpha. Similarly, in the case of base also, your OH minus is equal to C alpha. So, straight away if you are asked, in some cases if alpha given, Ka given, concentration also given, what is the concentration of OH minus, what is the concentration of H plus, questions can be asked. In that case, straight away what you have to do, OH minus is equal to C alpha, OH minus is equal to C alpha. So, from that OH minus you can find out. From OH minus you can find POH also, from POH pH also. Okay? Like these questions can be asked. So, just a simple modification, instead of a weak acid, what you are using? A weak base. So, the formula accordingly slightly changes. Instead of H plus, you are having OH minus, instead of Ka, you are having Kb. So, please get familiarized with these things. So far what we have seen is certain terminologies and also Ostwald's dilution law. Problems we have seen already based on Ostwald's dilution law. Students should be aware of that, practice those areas. Okay. Now, what we are going to see is concepts of acids and bases. We all know very well about acid and a base, everybody knows. Acid is one which has sour taste, which turns blue litmus into red. This is a classical concept. Similarly, for a base, what happens? Base turns red litmus into blue. These you have studied in lower classes. Now, we are going to see some important concepts related to acids and bases. These acids and bases concepts plays a vital role in NEET also. Questions certainly can be asked in these areas. Even though it is a theoretical part, students should clearly read each and every line related to this part. Okay. Now, what you are going to see, the first concept is Arrhenius concept. What Arrhenius says is, according to him, an acid is a substance which furnishes H plus ions in solution, and similarly a base is a substance which furnishes OH minus ions in solution. For example, if you take HCl, when you put HCl in water, what happens? It dissociates and gives H plus. So, according to Arrhenius, HCl is an acid. Similarly, H2SO4 is an acid, H3PO4 is an acid. You take acetic acid, that also gives H plus. What is the difference between these two? HCl is a strong acid, acetic acid is a weak acid. Okay. That is what Arrhenius told. So, what is the limitation of Arrhenius? What is the main thing is, there are certain substances which do not contain H plus and OH minus, but behave as acids. That is the most important thing. For example, you take ammonia. Ammonia, we know very well it is a base, but it does not contain OH minus. It will not give OH minus in solution. Similarly, there are certain oxides, for example, CO2, SO2. These are all acidic oxides. These will give acid. These behaves as acids, but the most important thing, it does not contain H plus. This is the limitation regarding Arrhenius. Okay. The next thing is Bronsted-Lowry concept. This concept is purely based on H plus ions alone. According to this concept, an acid is one which gives H plus and a base is one which accepts H plus. That is the difference. Here there is no OH minus ions involved, only it is based on H plus ions alone. For example, you take HCl, it gives H plus, so it is an acid. One problem is solved with regard to Arrhenius. Arrhenius could not explain ammonia as a base, whereas this concept clearly explains ammonia as a base. How? Ammonia, what it does, it accepts a proton. Ammonia, it accepts a proton. So, according to Lowry-Bronsted concept, when it accepts proton, it is a base. So, very clearly based on this concept, we can clearly explain ammonia as a base. Okay. Advantages is, basic character of certain substances like sodium carbonate can be explained, and then this theory can explain the acid base concept in the non-aqueous medium. Non-aqueous medium means apart from water. Water is an aqueous medium apart from water, or the most important thing, even in the absence of solvent. We need not to have any solvent to explain acid base nature. Okay. What is the limitation here? Here the most important thing is, there are certain acids, similarly bases, which do not contain even H plus. That is the most important thing. One example given here. For example, calcium oxide. We know very well it is a basic oxide, but it does not contain H plus. Similarly, SO3 we know very well it is a acidic oxide, it does not contain H plus. These two react and it forms a salt, we know that it is calcium sulphate. These two react, an acid, a base react producing salt, but no H plus involved. This is the limitation of Lowry-Bronsted concept. Similarly, another thing is substances like BF3, AlCl3, these substances they behave as acids, but Bronsted-Lowry could not explain. The reason being why they are considered as acids. The thing is BF3, boron, aluminum both belong to 13th group family. 13th group family has less than octet electrons, less than 8 electrons. For example, if you take BF3, it forms 3 bonds. So, totally how many electrons there? 6 electrons there. If 8 electrons present in the outermost shell, then only the substance will be neutral. Since it is short of electrons or otherwise it is in need of electrons, it tends to accept electrons, but no H involved, but still they are considered as acids. That could not be explained by Bronsted-Lowry concept. The next and the most important concept is Lewis acid base concept. What is that concept? According to Lewis, an acid is electron acceptor, that means accepting a pair of electrons. Similarly, a base, what it will do? It will donate pair of electrons. So, now previously what I told, BF3, AlCl3 could not be explained by Bronsted-Lowry concept, whereas here it can be explained by Lewis, because totally it involves electrons. Now, what we are going to see is types of Lewis acids. There are 4 types, we are going to see one by one. First one, neutral molecules. Neutral molecules, 2 examples, BF3, AlCl3. As I told already, both belong to 13th group elements. 13th group elements electron deficient. So, automatically they will tend to accept electron, that is why they fall into this category Lewis acids. Next one, cations given. Cations means electron deficient, we know very well. So, they tend to accept. The next one, molecules having central atoms with empty d orbitals. Empty d orbitals, what it will do? It will tend to accept electrons and form bonds. So, they also fall into this category Lewis acids. And the last one is molecules containing a multiple bond between 2 different heteroatoms having different electronegativities. Example given here is CO2. In the case of CO2, what happens? Multiple bonds present between carbon and oxygen, both differ in their electronegativities, right, and that is why it falls into this category. So, CO2 is a Lewis acid. So, 4 types we have seen. First one neutral molecules, second one cations, third one empty d orbital species, and the fourth one is multiple bonds species. Then next types of Lewis bases. In the case of bases, the most important thing is the neutral molecules type should have lone pair of electrons. 2 examples given, you can write many examples. I have given here 2, ammonia, water, similarly alcohol, amines, everything you can include. In all these cases, the central atom is having a lone pair of electron, at least a lone pair, or it may have more than 1 pair. You see ammonia, it has 1 pair, you see water, it has 2 pairs. So, what it will do? It will tend to donate, and so it behaves as a base. Okay. Then next thing, what is given? Negative ions. So, it is just opposite to positive ions. Positive ions tend to accept, negative ions tends to donate. Few examples given, students should master this. All negative ions like F minus, Cl minus, Br minus, Cn minus, these negative ions they have excess electron. so they tend to donate, and so they all behave as Lewis bases. So, the next one is limitations of Lewis theory. The first point is it cannot explain the strength of acids and bases. Okay. The second point, the most important thing with related to Lewis is it consider the formation of the bond as actually a coordinate bond. The reaction between acid and base results in the formation of a salt tends to form a coordinate bond. But actually reactions between hydrochloric acid or sulfuric acid with strong bases resulting in the formation of a salt, they do not form any coordinate bond. So, actually according to Lewis, these acids will not fall into that category. The next point, generally reactions involving inorganic acids are quite fast, inorganic acids are fast, but actually as Lewis suggests that there is coordinate bond formation, those reactions involving HCl sulfuric acid will not fall into the Lewis concept, because first thing it does not involve any coordinate bond, and the second thing the reaction takes place very fast. So, the next part what we are going to see is ionic product of water. The term itself clearly says product involving ions. First thing, water, it undergoes auto ionization or self ionization. When water it undergoes self ionization, what it will produce? It produces H plus ions and OH minus ions. Now, you take two molecules of water, it is in equilibrium with these ions, that is hydronium ion H3O plus and hydroxide ion OH minus. Now, the neutral molecule equilibrium with ions, which is nothing but ionic equilibrium. The next thing you have to write equilibrium constant. Equilibrium constant is product of concentration of ions of the product to product of concentration of the ions of reactants, those ratio product by reactant you should write, that is conventional or traditional. Okay. So, H3O plus into OH minus comes in the numerator, your H2O into H2O, that is H2O square, comes in the denominator. We know very well that water it ionizes very feebly. So, unionized water molecules almost there, it does not change, concentration does not change. So, you are taking H2O square as another constant, you are taking it as constant. So, already you are having equilibrium constant K, now you are having H2O square as constant. These two constant when you multiply, you are getting a new constant, that is nothing but Kw. Kw is equal to H3O plus into OH minus. Now, it is very clear, H3O plus comes from water, OH minus comes from water. These are product of ions or ionic product. So, that is why ionic product of water is nothing but Kw. This is very important formula, you should remember, you should keep it in mind. You have to do these problems, master this, questions certainly will come in these areas, previously it has been asked. Okay, thank you.
இந்நிகழ்ச்சியை பற்றிய தங்களின் மேலான கருத்துக்களை கீழ்க்கண்ட முகவரிக்கு கடிதம் மூலமாகவோ மின்னஞ்சல் மூலமாகவோ குறுஞ்செய்தி மூலமாகவோ தெரியப்படுத்தலாம். அனுப்ப வேண்டிய முகவரி சிறப்பு அலுவலர் கல்வி தொலைக்காட்சி 8ஆம் தளம் அண்ணா நூற்றாண்டு நூலகம், காந்தி மண்டப சாலை, கோட்டூர்புரம், சென்னை 6085. தொலைபேசி எண் 7824015000.